Good morning. Today I'm going to create 3 short videos on doing test of hypothesis for means. Okay, so I'm going to do 3 examples, and our population parameter is that we believe that the national listing price of homes is $280,000. Our first scenario is that we're going to look at New England region and see if in New England the listing of homes is higher than the national average. So the first thing you do is you define your parameter. Here it's means, so we're doing mu, the true mean listing average for New England region. Our null hypothesis is that we believe that the true population mean for the U.S. is 280,000. So we set that equals. Our hypothesis is that we believe that New England is higher than 280,000. When we do a test of hypothesis, we must determine ahead of time what we want to set our alpha. This is how much error we're willing to accept for making a mistake with our conclusions. So we collect our information. We're going to do a random sample of 30 listings. And when I did that, I got the mean for the 30 households, the mean for the 30 listings to be $318,000. And that's the sample mean for our sample of 30. And I got the standard deviation of $98,000. Now, in statistics, it's very important to kind of get an idea as to what you think the result is. That's why we ask you to draw the normal graph. And it doesn't have to be an artist rendition or anything like that. This is just a normal graph. Probably I could have done a better job doing the normal graph, but okay, so the normal graph looks more like this. All right, and for our variable x, our mean is at our population, which is 280,000, I'm going to abbreviate it K. Our sample right here is 318K. And this area right here is the p-value. If we get a small p-value, we're going to reject the null hypothesis. And if we get a big p-value, we're going to fail to reject the null hypothesis. So now the t statistic that we use, which will have a degrees of freedom equal to our 30 minus 1 of 29. We calculate our t statistic, which is 318 from our sample, minus the population parameter, which is 280,000 for the nation, divided by the standard deviation, 98,000 divided by the square root of n, which is 30. So we're going to get a t-value, of 2.12. And so I'm going to add that information here. The t-statistic has a mean of 0, and the t-value here is 2.12. Now go back to the empirical rule, and remember you have 68, 95, 99.7. Right? So 68% of the middle portion of this is going to be within 95, one standard deviation away is going to be 68%. 2 standard deviations, which were basically 2 standard deviations away. This middle here, okay, when it's 2 standard deviations, is going to be 95% based on that rule. So our guesstimate is that over here, we're going to estimate that this is 2.5%, because over here is 2.5%. All right, so when we find our p-value, we're thinking that it's going to be around 2.5%. So now we're going to find the p-value, which is the probability that t is greater than or equal to 2.12. And there's a lot of different ways to do that. You can do that in Excel, graphing calculator. There's online apps. And you're going to get a value of 0.021. So this p-value, we were pretty close. We said it was going to be about 2.5%, is 0.021. So what do we do with that information? We have to write our conclusion. And there's 3 parts that you have to clearly state in the conclusion. The first thing is that you look at our p-value, 0.021, and compare it to alpha. Since it is less than alpha, we reject the null hypothesis. So that's the second part of our conclusion. Then, because we reject the null hypothesis, we have convincing evidence that the list price in the New England region is higher than the national average. Okay. So that's the first scenario. This is a right tail test, and we rejected the null hypothesis. I hope you found this helpful, and I will be doing 2 more.